Alright, so left Riemann sums here. Okay, again, remember we said that the left-hand side of the rectangle, or the left upper vertex, will represent the height. Okay, in comparison to what we did yesterday where it was the right-hand Riemann sum. Good? So again, start off by finding your delta x, which is the b minus a over n. We get 1. So let's do the expanded form. Let's figure out the area that's being covered here, the area of each rectangle, and add them up. What would the area of the first rectangle be? What's the height? 4 times the width, 1. Plus, what's the area of the next rectangle? 3 times 1. Plus, the area of the next one? 4 times 1. Plus, the area of the next one? 7 times 1, right? Okay. So we know that that's just the same thing as 1 times 4 plus 3 plus 4 plus 7. So what does that give us?
18.
18? What did we get yesterday when we did it, but with the right Riemann sum? Anybody remember? 26, right? So yesterday was an over approximation, right? Just by looking at the picture. And today, by looking at this picture, it's a what? It's the same exact picture, but now it's on. Okay, here we were over, right? Here we're what? We're under, right? Because we're actually going all the way to 3, so we're missing this space here also. You can't see it, but we're missing that one, and that one. So this is an under approximation. So what do you think the actual area under the curve would be? Something between 18 and 26. Okay. So tomorrow we'll do midpoint Riemann sums. So instead of using the left or the right, you're going to use the middle of that interval to figure out your height and draw your rectangle. Okay? So we'll see how that is. That's actually going to be like an average between the left and the right. Good? Maybe? Alright, so let's keep going. When we work these guys out, okay, we need to be able to figure out the endpoints. Okay, because we need to be able to plug those numbers into my function to figure out the heights. How do I know that I need to use -1, 0, 1, and 2 and not 3? Okay, so we need to be able to figure that out. So, let's see. How did they get -1? On yesterday's example with the right Riemann sums, all we needed to do was add delta x to the original value, right? Here, what do I need to add to -1 to get -1? This -1, I'm getting it from my endpoint. Why do I need to add 0? We're doing a what kind of Riemann sum? Left, right? So the starting point will always be the first left endpoint, right? You understand? If I add delta x, it gets me to what? To 0. How can I come back over here? Take away delta x? Okay. Think about that. If I want to get to 0 and I'm at -1, what do I have to do? Plus 1? Okay. That's really like adding how many delta x's? 2, and then taking away 1? Okay. If I want to get up to 1, what would I do? So that's 2, right? 1 delta x, 2 delta x. Yes? If I want to get all the way to 2, what would I do? Plus 3? It's actually 1, 2, 3, 4 delta x, take away 1 delta x. Yeah? If we try to apply yesterday's formula. Okay? The really easy way of doing this is by making a table and putting your starting value. So my starting value is what? -1. And then all you have to do is add the width. So what was my width here? 1. Right? So I would say -1 plus 1 0, plus 1, plus 1, plus 1, 3. And I stop there. Why do I stop at 3 on it? That's the last boundary, right? We're going up to 3. And then to decide which endpoint to pick, I would pick which one. If I'm doing left Riemann sum. So 1 on the left, right? So negative 1. And then between these two, which one would I pick? 0. And then between these two, 1. And then between these two. Why do I want to be able to figure out what numbers to pick, what x value? If I don't have a graph. What am I going to do with those numbers? What do I need them for? I need them to plug them into the function to be able to find the what? The height. So if I don't have a graph, I still need to be able to figure out what numbers to use. You understand? Okay? So it's important. So what would the area be rewritten as if, let's say, I didn't have this picture here and I wanted to find it out another way, but I knew what my endpoints had to be. So we would say g of what? Negative 1, that's the first height, times 1. So g of negative 1 is actually like what? 4, right? Plus g of 0 times 1. G of 0 is actually 3. Plus g of 1 times 1 plus g of 2 times 1. I pick the left endpoint between each one all the time. You understand? If we were doing right, then which ones would I use? 0, 1, 2, 3. You understand? If we're doing midpoint, then what would I pick? Negative 0.5 and then 0.5 and then 1.5 and then 2.5. You understand? So if we're doing midpoints, when we make this little table, we leave a gap in the middle. So we say negative 1, leave a gap, 0. Leave a gap, 1. Leave a gap, so on and so forth. So that way you can put what you're going to actually use in the gaps. And then just pay attention to those. We'll talk about that method later. So far so good? Alright, so in order to come up with the sigma notation, it's a little complicated, just kind of taking it off of here. So what we're going to do is we're going to jump to the bottom, and we're going to try to come up with the general form, and then maybe from there we'll be able to go back and write the specific one, okay? And I made a mistake here. This shouldn't be right. This is for the left Riemann sum, okay? So fix that, please. And we're using f of x bounded by x equals a, x equals b, and the x-axis. And we're doing n intervals of equal length. So delta x, what was it again? B minus a over n. Okay. Now we need to be able to figure out the endpoints that we're going to use to be able to plug into my function. Okay? I need to be able to do that because that's what's going to go in my function, that's what's going to go in my formula. Right? So the first one we know is just the same as a. Right? Whatever that endpoint was at the beginning is going to be my first left endpoint. Right? The second one is going to be a plus what? What specifically would it be here? How many delta x? 1 delta x, right? So if I'm here, and I want to get to the next endpoint that I need to use, I need to add 1 delta x, right? If I start at A and I want to get all the way to the next one, what would I have to add? 2 delta x. What if I want to get to the kth endpoint? So that would be A plus k minus 1 delta x. So this one's a little bit different from yesterday, right? When you compare this number right here and this number, what do you notice about this one? It's always what? 1 less than that actual value there, right? So that's why they told me k minus 1. Yesterday's on the right Riemann sum, were they different? Wait, just kidding. That's not yesterday. No. You're like, no. Were they different here? No, 1, 1, 2, 2, 3, 3. That's why we just put what? k delta x. Do you understand? That's why when I was up here, I was saying add 2 delta x and then take away 1 delta x. Because that's what we would get if we were to distribute this, right? We'd get k delta x minus delta x. Okay? How would I find the area of just one rectangle? I'm going to say the k rectangle. F of a plus k minus 1 delta x, that's the height, times delta x, the width. I needed to be able to figure this out because I need to know what to plug into the function. Do you understand? Yep. And how would I figure out the area of a whole bunch of them? Let's say I want the area of n rectangles. I use the sigma notation, right? So that would be from where to where? From 1 to n. Is this always 1? Yes. Why? Represents the rectangles that you're adding, right? Okay. Of f of a plus k minus 1, right? Delta x times delta x. So it's almost the same formula that we used yesterday for the right Riemann sum, but if you think about it, we're not going to the right point, we want to use the left one. So yesterday I was going here, well I don't want to go here, I want to come back over here, right? So what do I need to do to this number? Take away 1, right? So instead of being here, I got to take away 1. Instead of being here, I got to take away 1. Do you understand? Okay? So the specific formula for the left Riemann sum is going to be what? What we just wrote. And we're going to keep repeating it so we can help ourselves remember it. Okay? That one's going to be the summation from I equals 1 to n of f of a plus, in this case it would be I minus 1 delta x times delta x. Not too bad? Think you can remember that? Maybe? Alright, so let's come back up here to this example and see if we can write the one for this one. Okay? Do you want to go straight to the one for the whole thing? Or do you want to write the formula for just one? Can we just go for the whole thing? Alright, so this would be the area of how many rectangles do we have up here? 4. So that's going to be the summation from I equals 1 to 4 of g of, we need a. What was a in this problem? Negative 1 plus parentheses I minus 1, that doesn't change, that's always going to be there, times delta x. What was delta x in this problem? 1 times delta x, which was 4. And if we type that in our calculator, what should we get? 18, because that's the same answer I got it. Do we understand? Yeah? Pretty easy? The hard part is discovering the formula. Once you discover it, that's it. It's just a matter of applying it and using it, right? Okay, so we've discovered it, so let's practice it. Let's get it down. Ready? Couple of examples. So at the top here, let's write the formula again. Because we're doing left-hand Riemann sum. What's my formula for that one? The summation I equals 1 n of f of a plus I minus 1 delta x times. Ultimately, that's the formula I'm going to need for all of these problems. Ready? So let's do it, okay? We're working with the same function we were working with yesterday. We're going from 1 to 7, but now they want us to calculate the left-hand Riemann sum using 3 intervals. So first thing we do is we find the what? The width, so let's do it. What's the width gonna be if I want 3 rectangles? 7 minus 1 divided by 3? 2. Let's draw our rectangles. So if I'm starting at 1 and I'm going to 7, my delta x is 2, so my first number would be there 3, and then my next one would be at what? 5. Between 1 and 3, which one's on the left-hand side? 1. So that's the one I need to use to draw my rectangles, to figure out the height. Yesterday we used which one? We used 3, right? Now between 3 and 5, which one's on the left? 3. So go up, touch the graph, go to the side and come back. Between 5 and 7, 5 is on the left. So what does this look like? It's going to be an over or an under approximately? An over, right? So this is probably going to be more than what number? Not 18, this was a different graph. What was this one going to be, remember? 40, right? So it's probably going to be more than 40. All right, so let's figure it out. So 2, what's the area of any rectangle in there? The ith